Hang gliding is an air sport, a recreational activity in which a pilot flies a light, non-motorized foot-launched heavier-than-air aircraft called a hang glider. Most modern hang gliders are made of an aluminium alloy or composite frame covered with synthetic sailcloth to form a wing. Typically, the pilot is in a harness suspended from the airframe and controls the aircraft by shifting body weight in opposition to a control frame. Early hang gliders had a low lift-to-drag ratio, so pilots were restricted to gliding down small hills. By the 1980s, this ratio significantly improved, and since then pilots can soar for hours, gain thousands of meters of altitude in thermal updrafts, perform aerobatics, and glide cross-country for hundreds of kilometers. The Fédération Aéronautique Internationale in national airspace governing organizations control some regulatory aspects of hang gliding. Obtaining the safety benefits of being instructed is highly recommended. History. The earliest forms of gliding had existed in China. By the end of the 6th century A.D., the Chinese had managed to build kites large and aerodynamic enough to sustain the weight of an average-sized person. It was only a matter of time before someone decided to simply remove the kite's strings and see what happened. Most early glider designs did not ensure safe flight. The problem was that early flight pioneers did not sufficiently understand the underlying principles that made a bird's wing work. Starting in the 1880s, technical and scientific advancements were made that led to the first truly practical gliders. Otto Lilienthal built controllable gliders in the 1890s, with which he could ridge soar. His rigorously documented work influenced later designers, making Lilienthal one of the most influential early aviation pioneers. His aircraft was controlled by weight shift and is similar to a modern hang glider. Hang gliding saw a stiff and flexible wing hang glider in 1904, when Yann Levezzari flew a double lateen sail hang glider off Burke Beach, France. In 1910 in Breslau, the triangle control frame with hang glider pilot hung behind the triangle in a hang glider was evident in a gliding club's activity. The biplane hang glider was very widely publicized in public magazines, with plans for building such biplane hang gliders were constructed and flown in several nations since Octave Chanute and his tailed biplane hang gliders were demonstrated. In April 1909, a how-to article by Carl S. Bates proved to be a seminal hang glider article that seemingly affected builders even of contemporary times, as several builders would have the first hang glider made by following the plan in his article. Volmer Jensen with a biplane hang glider in 1940 called VJ11 allowed safe 3-axis control of a foot-launched hang glider. On November 23, 1948, Francis Rogallo and Gertrude Rogallo applied for a kite patent for a fully flexible kitted wing with approved claims for its stiffenings and gliding. Uses the flexible wing, a Rogallo wing, which in 1957 the American Space Agency NASA began testing in various flexible and semi-rigid configurations in order to use it as a recovery system for the Gemini space capsules. The various stiffening formats and the wing's simplicity of design and ease of construction, along with its capability of slow flight and its gentle landing characteristics, did not go unnoticed by hang glider enthusiasts. In 1960 to 1962, Barry Hill Palmer adapted the flexible wing concept to make foot-launched hang gliders with 4 different control arrangements. In 1963, Mike Burns adapted the flexible wing to build a towable kite hang glider he called Skiplane. Indiana 1963, John West. Dickinson adapted the flexible wing airfoil concept to make another water-ski kite glider. For this, the Fédération Aéronautique Internationale vested Dickinson with the hang gliding diploma for the invention of the modern hang glider. Since then, the Rogallo wing has been the most used airfoil of hang gliders. Components: hang glider sailcloth. There are basically two types of sail materials used in hang glider sails: woven polyester fabrics, and composite laminated fabrics made of some combination of polyester film and polyester fibers. Woven polyester sailcloth is a very tight weave of small diameter polyester fibers that has been stabilized by the hot press impregnation of a polyester resin. The resin impregnation is required to provide resistance to distortion and stretch. This resistance is important in maintaining the aerodynamic shape of the sail. Woven polyester provides the best combination of lightweight and durability in a sail with the best overall handling qualities. Laminated sail materials using polyester film achieve superior performance by using a lower stretch material that is better at maintaining sail shape but is still relatively light in weight. The disadvantages of polyester film fabrics is that the reduced elasticity under load generally results in stiffer and less responsive handling, and polyester laminated fabrics are generally not as durable or long-lasting as the woven fabrics. Triangle control frame. In most hang gliders, the control is and has been achieved using a horizontal bar held by the pilot, also known as triangle control frame, control bar or base bar. This bar is usually pulled to allow for greater speed. Either end of the control bar is attached to an upright where both extend and are connected to the main body of the glider. This creates the shape of a triangle or a frame. In many of these configurations, additional wheels or other equipment can be suspended from the bottom bar rod ends. Images showing a triangle control frame on Otto Lilienthal's 1892 hang glider prove that the technology of such frames has existed since the early design of gliders, but he did not mention it in his patents. A TCF shows also in octave harness designs. It was a major part of the now common design of hang gliders by George A. Spratt from 1929. The most simple airframe that is cable-stayed was demonstrated in a Breslau Gliding Club hang gliding meet in a battened wing hang glider in the year 1908. Hang glider historian Stefan Nitsch has collected instances also of the U-control frame used in the first decade of the 1900s. The U is variant of the A-frame. Training and safety. Due to the poor safety record of early hang gliding pioneers, the sport has traditionally been considered unsafe. Advances in pilot training and glider construction have led to a much improved safety record. Modern hang gliders are very sturdy when constructed to Hang Glider Manufacturers Association (BHPA), Deutsche Hangergliederverband, or other certified standards using modern materials. Although lightweight, they can be easily damaged, either through misuse or by continued operation in unsafe wind and weather conditions. All modern gliders have built-in dive recovery mechanisms such as laugh lines in king-posted gliders, or sprogs in topless gliders. Pilots fly in harnesses that support their bodies. Several different types of harnesses exist. Pod harnesses are put on like a jacket and the leg portion is behind the pilot during launch. Once in the air, the feet are tucked into the bottom of the harness. They are zipped up in the air with a rope and unzipped before landing with a separate rope. A cocoon harness is slipped over the head and lies in front of the legs during launch. After getting into the air, the feet are tucked into it and the back is left open. A knee hanger harness is also slipped over the head, but the knee part is wrapped around the knees before launch and just pick up the pilot's leg automatically after launch. A supine or supine harness is a seated harness. The shoulder straps are put on before launch, and after takeoff the pilot slides back into the seat and flies in a seated position. Pilots carry a parachute enclosed in the harness. In case of serious problems, the parachute is manually deployed and carries both pilot and glider down to earth. Pilots also wear helmets and generally carry other safety items such as knives, light ropes, radios, and first aid equipment. The accident rate from hang glider flying has been dramatically decreased by pilot training. Early hang glider pilots learned the sport through trial and error, and gliders were sometimes home-built. Training programs have been developed for today's pilot with emphasis on flight within safe limits, as well as the discipline to cease flying when weather conditions are unfavorable, for example, excess wind or risk clouds suck. In the UK there is 1 death per 116,000 flights, a risk comparable to running a marathon or playing football for a year. Most pilots learn at recognized courses which lead to the internationally recognized International Pilot Proficiency Information Card issued by the FAI. Launch techniques include foot launching from a hill, tow launching from a ground-based tow system, aero towing, powered harnesses, and being towed up by a boat. Modern winch tows typically utilize hydraulic systems designed to regulate line tension. This reduces scenarios for lockout as strong winds result in additional length of rope spooling out rather than direct tension on the tow line. Other more exotic launch techniques have also been used successfully, such as hot air balloon drops from very high altitude. When weather conditions are unsuitable to sustain a soaring flight, this results in a top-to-bottom flight and is referred to as a sled run. In 1983, Dennis Cummings reintroduced a safe tow system that was designed to tow through the center of mass and had a gauge that displayed the towing tension. It also integrated a weak link that broke when the safe tow tension was exceeded. After initial testing in the Hunter Valley, Dennis Cummings, pilot, John Clark, driver, and Bob Silver, aficionado, began the Flatlands hang gliding competition at Parks, NSW. The competition quickly grew from 16 pilots the first year to hosting a world championship with 160 pilots towing from several wheat paddocks in western NSW. In 1986, Dennis and Red Truck took a group of international pilots to Alice Springs to take advantage of the massive thermals. Using the new system, many world records were set. With the growing use of the system, other launch methods were incorporated: static winch and towing behind a powered hang glider, or ultralight soaring flight and cross-country flying. A glider in flight is continuously descending. To achieve an extended flight, the pilot must seek air currents rising faster than the sink rate of the glider. Selecting the sources of rising air currents is the skill that has to be mastered if the pilot wants to achieve flying long distances. Known as cross-country, rising air mass is derived from the following sources. Thermals. The most commonly used source of lift is created by the sun's energy heating the ground, which in turn heats the air above it. This warm air rises into columns known as thermals. Soaring pilots quickly become aware of land features which can generate thermals and the trigger points downwind, because thermals have a surface tension with the ground and roll until hitting a trigger point. When the thermal lifts, the first indicator are the swooping birds feeding on the insects being carried aloft, or dust devils, or a change in wind direction as the air is pulled in below the thermal. As the thermal climbs, bigger soaring birds indicate the thermal. The thermal rises until it either forms into a cumulus cloud or hits an inversion layer, which is where the surrounding air is becoming warmer with height, and stops stops the thermal developing into a cloud. Also, nearly every glider contains an instrument known as a variometer which shows visually the presence of lift and sink. Having located a glider pilot will circle within the area of rising air to gain height. In the case of a cloud street, thermals can line up with the wind, creating rows of thermals and sinking air. A pilot can use a cloud street to fly long straight-line distances by remaining in the row of rising air. Ridge lift. Ridge lift occurs when the wind encounters a mountain, cliff, or hill. The air is pushed up the windward face of the mountain, creating lift. The area of lift extending from the ridge is called the lift band, providing the air is rising faster than the glider's sink rate. Gliders can soar and climb in the rising air by flying within the lift band and at right angle to the ridge. Ridge soaring is also known as slope soaring. Mountain waves. The third main type of lift used by glider pilots is the lee waves that occur near mountains. The obstruction to the airflow can generate standing waves with alternating areas of lift and sink. The top of each wave peak is often marked by lenticular cloud formations. Convergence. Another form of lift results from the convergence of air masses, as with a sea breeze front. More exotic forms of lift are the polar vortices, which the Perlan project hopes to use to soar to great altitudes. A rare phenomenon known as morning glory has also been used by glider pilots in Australia. Performance. With each generation of materials and with the improvements in aerodynamics, the performance of hang gliders has increased. One measure of performance is the glide ratio. For example, a ratio of 12:1 means that in smooth air a glider can travel forward 12 meters while only losing 1 meter of altitude. Some performance figures as of 2006. Topless gliders. Glide ratio ~17:1. Speed range ~30 to 145 km per hour. Best glide at 45 to 60 km per hour. Rigid wings. Glide ratio ~20:1. Speed range ~35 to 130 km per hour. Best glide at ~50 to 60 km per hour. Ballast. The extra weight provided by ballast is advantageous if the lift is likely to be strong, although heavier gliders have a slight disadvantage when climbing in rising air. They achieve a higher speed at any given glide angle. This is an advantage in strong conditions when the gliders spend only little time climbing in thermals. Stability and equilibrium. Because hang gliders are most often used for recreational flying, a premium is placed on gentle behavior, especially at the stall and natural pitch stability. The wing loading must be very low in order to allow the pilot to run fast enough to get above stall speed. Unlike a traditional aircraft with an extended fuselage and empennage for maintaining stability, hang gliders rely on the natural stability of the flexible wings to return to equilibrium in yaw and pitch. Roll stability is generally set to be near neutral. In calm air, a properly designed wing will maintain balanced trimmed flight with little pilot input. The flex-wing pilot is suspended beneath the wing by a strap attached to his harness. The pilot lies prone within a large, triangular, metal control frame. Controlled flight is achieved by the pilot pushing and pulling on this control frame, thus shifting his weight fore or aft, and right or left in coordinated maneuvers. Roll. Most flexible wings are set up with near-neutral roll due to side slip. In the roll axis, the pilot shifts his body mass using the wing control bar, applying a rolling moment directly to the wing. The flexible wing is built to flex differentially across the span in response to the pilot-applied roll moment. For example, if the pilot shifts his weight to the right wing trailing edge flexes up more than the left, allowing the right wing to drop and slow down. Your axis is stabilized through the sweep back of the wings. The swept planform, when yawed out of the relative wind, creates more lift on the advancing wing and also more drag, stabilizing the wing in yaw. If one wing advances ahead of the other, it presents more area to the wind and causes more drag on that side. This causes the advancing wing to go slower and to fall back. The wing is at equilibrium when the aircraft is traveling straight and both wings present the same amount of area to the wind. The pitch control response is direct and very efficient. It is partially stabilized by the sweep of the wings. The wing center of gravity is close to the hang point and, at the trim speed, the wing will fly hands-off and return to trim after being disturbed. The weight shift control system only works when the wing is positively loaded. Positive pitching devices such as reflex lines or washout rods are employed to maintain a minimum safe amount of washout when the wing is unloaded, or even negatively loaded. Flying faster than trim speed is accomplished by moving the pilot's weight forward in the control frame, flying slower by shifting the pilot's weight aft. Furthermore, the fact that the wing is designed to bend and flex provides favorable dynamics analogous to a spring suspension. This provides a gentler flying experience than a similarly sized rigid winged hang glider. Instruments. To maximize a pilot's understanding of how the hang glider is flying, most pilots carry instruments, the most basic being a variometer and altimeter, often combined. Some more advanced pilots also carry airspeed indicators and radios. When flying in competition across country, pilots often also carry maps and/or GPS units. Hang gliders do not have instrument panels as such, so all the instruments are mounted to the control frame of the glider or occasionally strapped to the pilot's forearm. Variometer gliding pilots are able to sense the acceleration forces when they first hit a thermal, but have difficulty gauging constant motion. Thus it is difficult to detect the difference between constantly rising air and constantly sinking air. A variometer is a very sensitive vertical speed indicator. The variometer indicates climb rate or sink rate with audio signals and/or a visual display. These units are generally electronic, vary in sophistication, and often include an altimeter and an airspeed indicator. More advanced units often incorporate a barograph for recording flight data and/or a built-in GPS. The main purpose of a variometer is in helping a pilot find and stay in the core of a thermal to maximize height gain, and conversely indicating when he or she is in sinking air and needs to find rising air. Variometers are sometimes capable of electronic calculations to indicate the optimal speed to fly for given conditions. The MacCready theory answers the question on how fast a pilot should cruise between thermals, given the average lift the pilot expects in the next thermal climb and the amount of lift or sink he encounters in cruise mode. Some electronic variometers make the calculations automatically, allowing for factors such as the glider's theoretical performance, altitude, hook-in weight, and wind direction. Radio pilots use two-way radio for training purposes, for communicating with other pilots in the air, and with the ground crew when traveling on cross-country flights. One type of radios used are PTT handheld transceivers, operating in VHF-FM. Usually a microphone is incorporated in the helmet, and the PTT switch is either fixed to the outside of the helmet, or strapped to a finger. Operating a VHF band radio without an appropriate license is illegal in most countries that have regulated airwaves, so additional information must be obtained with the national or local hang gliding association. As aircraft operating in airspace occupied by other aircraft aircraft. Hang glider pilots also use the appropriate type of radio. It can, of course, be fitted with a PTT switch to a finger and speakers inside the helmet. The use of aircraft transceivers is subject to regulations specific to the use in the air, such as frequencies restrictions, but has several advantages over FM radios used in other services. First is the great range it has because of its amplitude modulation. Second is the ability to contact, inform and be informed directly by other aircraft pilots of their intentions, thereby improving collision avoidance and increasing safety. Third is to allow greater liberty regarding distance flights in regulated airspaces, in which the aircraft radio is normally a legal requirement. Fourth is the universal emergency frequency monitored by all other users and satellites and used in case of emergency or impending emergency. GPS. GPS can be used to mark the flight path as the pilot flies, as it can be interesting to view a GPS track of a flight when back on the ground, to analyze flying technique, and to assist flight performance in competitions and cross-country flying, where restricted airspace needs to be considered. Records. Records are sanctioned by the FI. The world record for straight distance is held by Dustin B. Martin, with a distance of 764 kilometers in 2012, originating from Zapata, Texas. Judy Ledden holds the altitude record for a balloon-launched hang glider, 11,800 meters at Wadi Rum, Jordan on October 25, 1994. Ledden also holds the gain of height record, 3,970 meters, set in 1992. The altitude records for balloon-launched hang gliders. Competitions started with flying as long as possible and spot landings. With increasing performance, cross-country flying replaced them. Usually 2 to 4 waypoints have to be passed with a landing at a goal. In the late 1990s, low-power GPS units were introduced and have completely replaced photographs of the goal. Every 2 years there is a World Championship. The Rigidon Women's World Championship in 2006 was hosted by Questair in Florida. Big Spring, Texas hosted the 2007 World Championship. Hang gliding is also one of the competition categories in World Air Games organized by Fédération Aéronautique Internationale, which maintains a chronology of the FI World Hang Gliding Championships. Classes for competitive purposes. There are 3 classes of hang glider. Class 1, the flexible wing hang glider, having flight controlled by a wing whose shape changes by virtue of the shifted weight of the pilot. This is not a paraglider. Class 5, the rigid wing hang glider, having flight controlled by spoilers, typically on top of the wing. In both flexible and rigid wings, the pilot hangs below the wing without any additional fairing. Class 2, where the pilot is integrated into the wing by means of a fairing. These offer the best performance and the most expensive. In addition to typical launch configurations, a hang glider may be constructed for alternative launching modes other than being foot-launched. One practical avenue for this is for people who physically cannot foot-launch. Aerobatics. Hang gliders are not certified for aerobatic flight. Pilots perform aerobatics at their own risk. There are 3 basic maneuvers in a hang glider, not counting a loop, which is actually a climb over with the same entry and exit heading. The following descriptions are excerpts from a nationally recognized rules book. Official maneuvers. A figure with a bank angle of more than 90 degrees is a maneuver. Loop, a maneuver that starts in a wings level dive, climbs, without any rolling to the apex where the glider is upside down, wings level, and then returning to the start altitude and heading again without rolling, having completed an approximately circular path in the vertical plane. Spin. A spin is scored from the moment one wing stalls and the glider rotates noticeably into the spin. The entry heading is noted at this point. The glider must remain in the spin for at least 1/2 of a revolution to score any versatility spin points. Rollover, a maneuver where the apex heading is less than 90 degrees left to right of the entry heading. Climb over, a maneuver where the apex heading is greater than 90 degrees left to right of the entry heading. Comparison of gliders, hang gliders and paragliders. There can be confusion between gliders, hang gliders, and paragliders. Paragliders and hang gliders are both foot-launched glider aircraft. In both cases the pilot is suspended below the lift surface, but hang glider is the default term for those where the airframe contains rigid structures. The primary structure of paragliders is supple, consisting mainly of woven material.